Hello, this is part two of the Aleks exam Aleks exam part four. Aleks exam four. So let's just continue off. We stopped on question 14. So which graph below represents a circle x squared plus y squared 4x minus 2y plus 1 equals 0. So we have, what I would do is get all the x's. Let's kind of rearrange it. Let's get all the x's on one side and all the y. So we have an x squared here and a 4x. And then I'm going to leave a little blank space and you'll see what I'll do. And then let's do the y. So we have a y squared here plus a 2y with a little blank space. And then do you see this constant 1? I'm going to move it to the right by subtracting 1. Yeah. So what I'm going to put here is you're going to take half of your b and you're going to square it. So if your b is 4, take half of that. That's going to be 2. And I'm going to square that. That's going to be 4. So I'm going to add 4 here and add 4 there on the right side. Same thing here. Take half of your b. So if your b is 2, take half of that. That's 1. And then you're going to square that, which is 1. You add 1 there and add 1 there. So now you have x squared plus 4x plus 4 plus y squared plus 2y plus 1. And then on the right, 4 plus 1 is 5, minus 1 is 4. Okay, then what I'm going to do is put it in factor form, kind of like go backwards. So over here, x squared plus 4x plus 4, I can factor out as x plus half of your b. So my b is, if your b is 4, half of that is 2. And then close it with the parentheses and then we'll just then square it. So when you FOIL this out, you're going to get this. So it's kind of like going backwards, right? The same thing here. I'm going to put a parentheses. I'm going to put a y and then half of my b. So if my b is 2, half of that is 1. Square that. This is 1. And then what I'm going to do, so this is what we have it, this is what the standard form of a circle is. So now we can use this information to figure out our center. So my center is not positive 2, but negative 2. And then my y is not positive 1, it's negative 1. Okay, so it's like always the opposite. And then my radius is not 4, square root of 4, which is 2. Okay, so my center is going to be negative 2, negative 1, and then my radius is 2. So which of this graph gives you a center of negative 2, negative 1, radius 2? Is it A? No. Is it B? Maybe. It's no. Maybe so negative 1. That's off. Is it C? No. Wait, the center's off. Is it D? Negative 2, negative 1. I think the y stays the same. So I think the x is up. So it's negative 2, positive 1. Yes. So the y stays the same. I don't know why, but it does. The x, even though this is positive, it's really negative 2. And then my radius is not 4 square root of 4, which is 2. So which of these gives you a center of negative 2 and 1 and radius 2? think it's this one. Yes. Okay, 15, solve the inequality. So when you're dealing with inequalities, there are a few things that you must do or check. The first thing I've got to do is make sure there's nothing. You're gonna set up two inequalities. But first, before we do that, make sure there's nothing near the absolute value near. If there is, get rid of it. So if there was like a absolute value 3x plus 9 minus 9, 2, you got to get rid of this -9 by adding 9, and then you got to get rid of this 2 by dividing 2, right? So that's hypothetically, because there's nothing near the absolute value, we are fine. We can skip this step. Okay, step 2, make sure uh, right, this number right here is positive. So if it was a -27 and there's nothing near the absolute value, you can automatically say there's no solution. Okay, so it passes it because 27 is positive. So we can write out our two inequalities. The first one is 3x plus 9 is less than or equal to 27. And the second inequality would be 3x plus 9. Flip the sign, so it's going to be greater than or equal to -27. And then I'm going to solve for x, so I'm just subtract 9, subtract 10. And then 27 minus 9 is 18. Divide this by 3, you get 18 divided by 3 is 6. And then over here, I'm going to subtract 9, subtract 9. -27, -9 is 6. Divide this by 3, divide this by 3. I don't flip the sign because I'm not dividing by negative, and then -36 divided by 3 is -12. Okay, so if you put this on a number line, my smaller number is -12, my larger number is 6. And then the row of them don't circle because they have that equal sign. And then you follow the arrow. So x is less than 6, you're going to move the arrow to the left and not all the way. And then x is greater than -2, you can move the arrow to the right. So it connects like this. So that would be it. Yes, letter A. Okay, 16. What value describes the wide base in the polynomial graph? As x goes to -infinity. Okay, so this is like a limit problem. So they want to know what is the y value as x goes to -infinity. So you kind of need to know that behavior. So here's our graph, and they want to know as x goes to -infinity. So that means to the left. So this arrow keeps going upwards, right? This keeps on going up, and this one keeps going down. And then, so what is the y value as x goes to -infinity? It goes to positive infinity. So letter C. Okay, so as x goes to -infinity, the y value shoots up to positive infinity. Wait, this one. Which graph represents function f of x equals -7 over x plus 3? So this is a rational function. So what you need to know is you need to find the vertical asymptote, horizontal, and then a few points. So let's find the vertical asymptote. To find the vertical asymptote, you set the bottom to 0. So my bottom was x plus 3. Set that to 0 and solve for x. And to find the horizontal asymptote, you set y. So you need to know your asymptote rules. So on the top, the highest term is -7x to 0. And then on the bottom, it's x to the y, right? So you need to know the three rules. Is this top heavy, bottom heavy, or degrees are the same? It's definitely bottom heavy. So when it's bottom heavy, the horizontal asymptote is always going to be 0. So if you kind of draw a bit, it would look something like this. My vertical asymptote is -3. Dash line. My horizontal asymptote is y equals 0. So that's what we write here. Now we got to test the right and the left side. So on the, we got to test some points. So, or you could find the x or the y intercept. So I'm going to just test right points. So I can't use the x value -3, but I could use the x value -2. So that's -7. 3 minus 2 is 1. And then that gives you -2, 7. There's -2, -7. -7 is way down here, right? So it's going to go like this. And then over here, let's test the x value, not -3, but -4, because we can't use -3. So let's use -4. So it's going to be -7, -4 plus 3. That's -7. -4 plus 3 is -5. So you have a point at -4, -7. So being right here. So which of these graphs have a vertical asymptote at -3 and looks like this? Right. It was -3. It looks like this. There's your answer. Okay. Question 18. Find cosine of 120. So this is where this is a trig problem. What you got to do is locate 120 degrees in the unit circle. So 120 degree is a degree within the unit circle. It's right here. And what you got to do is figure out the coordinates of 120. So 120 has an x coordinate of -1/2 and a y coordinate of radical 3/2, right? So if it's a degree within the unit circle, did you know the cosine is just the x coordinate? And then the sine is the y coordinate. So this only works if it's a degree within the unit circle. If it's not, you probably have to do the SOHCAHTOA thing, right? So we just found our answers. It's just -1/2. Going. If cosine x equals radical 3/2, what is x? So what do we know? They give us a triangle, they give us an unknown theta, they give us a side length x, and then they give us a hypotenuse of 5, right? So what I could do is use what I know. So I'll use SOHCAHTOA, and I'm going to say cosine is adjacent over hypotenuse. So what that means is this radical 3 is your adjacent. This 2 is your hypotenuse. Can't spell. So radical 3 Oh, okay, so here's your theta. So my adjacent side is radical three, so this x is radical three, and then this two is the wait, no. Uh cosine, what is x? What is x? So geez, wait, uh let me think. Oh, I remember. Okay. So sorry, I had to think about it. Let's find theta. This is gonna be very helpful. I think this is related to the was it 30, 60, 90 triangle or the 45, 45, 90. So if I want to solve for theta, I could get rid of this cosine by multiplying cosine inverse, right? So theta is equal to cosine inverse, yeah, right, two. So if you put that in the calculator, that'll give us a degree of what? 30 degrees. So this theta here is 30, and then this angle here is 60, because this is a special triangle. It's a 30, 60, 90, not a 45, 45, 90. So now we could figure that out by we could find out x or this leg by using the rule. So what is the rule of a 30, 60? Is that something you must know? Here's a 90. You could set it up any way, like 60, you could put 30, but you need to know the rule. So the rule of 30, 60, 90 is it's so the rule for 30, 60, 90, it says that 30, the angle 30 has a side length of x. The angle 60 has this angle here has a side length of x radical 3. And then the hypotenuse is 2x. So do we have any of these values? Yes, we have the hypotenuse. So we could say 5 equals to 2x, right? And then we can solve for x by dividing both sides by 2. So x equals 5 halves. Or you could say, okay, but x, that's not our answer because 60 is facing x. So we know that 60 is equal to x radical 3. So my x is 5 halves times by radical 3. So that's C. I know that was a lot of work. So let me review what I did. I first figure out what angle, what this unknown angle, which is if I multiply both sides by cosine inverse, I get 30. And then I knew it was a 30, 60, 90. And then I kind of need to know the rule of 30, 60, 90. So here's the rule. 30 has a sine length of x. The angle 60 has a sine length of x radical 30. And then the hypotenuse is 2x. And then I figure out that we had a hypotenuse that's 5. So we could say phi equals 2x, divide this by 2, so x equals 5 halves. And then I could say that angle 60 has a side length of x rad of 3, so my x is 5 halves. Times y rad of 3. There you go. Okay. Here we have a word problem. All carbon-14 atoms undergo a natural and harmless nuclear reaction known as beta decay, whereby they turn into nitrogen-14. Given an initial mass of Mi of carbon-14, the final mass MF remaining after 2 years is given by the equation below. If an average blue whale has 0.002182 grams of carbon-14 in its bones, when it's alive, while it's replenished from the interaction with the environment and an atmosphere, how much will it represent 10,000 years after the whale's death? So they're saying that this whale had some kind of carbon-14 atoms, right? And then it just will disappear after some years. They wouldn't know how much is left. So you got to do it's just plug in values. I think our t is our time. So what they're saying is it's just saying m of 10,000. And then mi is your initial value. Your initial had 0.002182, and then it's e raised to the negative 0.123,121 times by the time, which was 10,000 years. So when we put that in the calculator, I'm gonna get 0.0065066. Yeah, this one is the closest. So it's just letter C. So yeah, you just plug in your values. We know that our T is that you plug in our time, and then MI is your initial value, which was 0.002182 grams. Okay, well, that's it. Okay, this one, find the amplitude and period of this function. So we have this cosine graph, y equals 7 half cosine of 2x minus pi plus 1. They want to know the amplitude and the period. So the amplitude is basically the absolute value of 7 halves. So it's actually a positive 7 halves. So that is our amplitude. The period, so the period for a sine or cosine is 2 pi over b. So what is my b value? The number in front of the x. So it's 2. So it's just pi. So my period is pi, and then my amplitude is 7 halves. So which one is that going to be? Oh, what about the phase shift? The phase shift is easy to find. All you got to do is you just got to set whatever the parentheses. So our parentheses is 2x minus pi. Set that to 0, and then you solve for x. So x equals pi over 2. it looks like it's going to be B. Amplitude is 7/2, period is pi, and then phase shift is pi half. So yeah, B. So um, we have 1 minus tan squared 3x times cosine squared 3x. So we're probably gonna do some kind of Pythagorean identities, but before we do that, is there something else I can do? Yes. You see this tan square x? That's the same thing as sine square x, or I carries, or x is not x is 3x over cosine square of 3x times by cosine square 3x, right? So this cancels. So you're left with 1 minus sine square 3x. And then what I'm going to do is use a Pythagorean identity, which is sine squared x plus cosine squared x. So that, and then I'm going to solve for it. I'm going to subtract sine squared x. So you get cosine squared x plus 1 sine squared x. So what you're going to do is replace this with cosine squared. And our x is not x, it is 3x. Letter B. Hey, in a certain small region of the woods, the rabbit population has exploded over the past 2 years, rising abruptly from 25 rabbits to 85 rabbits. Based on these 2 years of measurements, scientists have described this population growth with the equation below, where t represents the number of years after their initial measurement. Here they give you an exponential graph of p equals 20 times 2.00 raised to the t plus 5. Assuming this equation holds true, what would be the rabbit's population in 20 years? So it's pretty simple. All you got to do is replace your t with 20. So it's p of 20 equals 20 times 2.00 raised to the t, which is 20, plus 5. You get this number, 2097.525. Well, letter D. What was that? This one, simplify. Here we have a rational function because it's in a fraction. We have x bar plus 10x plus 24 on the top, all over x plus 6. What you want to do is try to factor, and hopefully something cancels. So on the top, that is simple factoring. You can factor this out as x, blank space. What you know is multiply 24 and when added gives you 10. Is that even possible? Yes. Positive 6, positive 4, and then all over x plus 6. And then as you can see, the x plus 6 cancels, so you're left with x plus 4. That's your answer. Letter C. 25, simplify 27 to the negative 1/9 raised to the negative 6. You could just easily put this in the calculator, or you can simplify a bit. When you raise, you technically multiply. So negative 1/9 raised to the negative 6, let's just multiply. So what is negative 9 times negative 1/9 times 6? That is a positive 6/9. Or that can be reduced by 3, so that's 6 divided by 3 is 2. 6 divided by 3 is 2, 9 divided by 3 is 3. So it's really 27 raised to the 2/3 now. And you can use a calculator, so that's going to be 9. Exactly 9. See, not too bad, right? This one, solve the equation. You could just cross multiply and they want you to solve for y. So if I cross multiply, you get y plus 21 x squared plus y. So one times this is this, and then it's going to be 3x plus 4 times 7x plus 6y minus 0. Okay, and then FOIL this out. So 3x times 7x is 21x squared because you multiply the constant and the exponent, and what this has a 1, this is a 1. So when you multiply, for example, x 3 times x2, you add the powers. Okay, continue. 3x times 6y is 10xy, and then 3x times -4 is -12x. And then over here, keep on boiling out, that's 28x. 4 times 6y is 24y. And then 4 times 4 is -16. Okay, over here we have y plus 21x squared plus 18xy. Let's see, can we cancel or combine? Um, I don't think so, but yeah, let's just move this to the right. So I want to solve for y, so maybe subtract 21x squared, subtract 18xy. So this cancels, you're left with y equals 0, 0. We're left with -12x plus 28x plus 24y minus 16. And is there anything you can combine? The 28 and the -12 is 16x. And then you have the 24y minus 16. And I just think you can just factor out 16. Or yeah, you're gonna factor out a 16 and you're gonna get y equals -16 over 23 or vice versa. So I'm gonna say D. This one, solve for x. Here we have a right triangle and we want to solve for x. So if you have a right triangle and you have two side lengths, you can automatically use Pythagorean theorem. You don't have to do SOHCAHTOA. So A is a leg, B is a leg, C is a hypotenuse. So be careful. What is my leg? One of my leg is 9, so 9 squared. My other leg is x, so that's gonna be x squared. And then my hypotenuse is 15. Why is 15 the hypotenuse? Because 15 is facing across the 90. So anything facing across the 90 is the hypotenuse. So 9 squared is 81, x squared, and then 15 squared is 225. Subtract 81 from both sides. Get x squared equals to 225 minus 81 is 144. Take the square root of both sides, you get 12. Okay, almost there. Rationalize the denominator. So this one's simple. X plus 1 over square root of x squared minus 1. To rationalize the denominator, I'll get rid of this radical on the bottom. All you gotta do is multiply top and bottom by x squared minus 1. That's it. So you get, on the top, you are left with x plus 1 times square root of x squared minus 1. And then on the bottom, the radical disappears, we're just left with x squared minus 1. And that would be letter B. Okay, this one is a log problem. Solve the equation. We have 2 log base 2 of x plus 5 is 4. So the first thing I'm going to do is get rid of this 2 by dividing both sides by 2. So now you have log base 2 of x plus 5 equals 4 divided by 2 is 2. Then what I'm going to do is put it in power form, exponent a to the y equals x. So you got to figure out your a, your y, and your x. So my a is the base, which is 2. My x is, oh, my y is going to be 2 as well. It's always on the right or left side. My x is going to be, the parentheses are right next to the log, so it's going to be x plus 5, right? So a to the y equals x, so it's going to be 2 to the y equals x, which is x plus 5. And then we want to solve for x, so 2 squares 4. To try 5, you get x equals negative 5. Letter D. Right, last problem. Find the domain and range of this log graph f of x equals log base 3 of x plus 1. So what we know is like you're dealing with log graph, it's the inverse of exponential. So what you need to know is you need to know in a log graph you have a vertical asymptote, right? You do have a vertical asymptote, and your vertical asymptote is whatever your horizontal shift is. So what is our horizontal shift? It is 3x plus 1. So I'm going to set that to 0 and set for x. Okay, I'm going to divide this by 3, and you get x equals. So what that means, it's going to look something like this. Let's pretend this is negative 1/3. I have a vertical asymptote like this. You have an x-intercept, and yeah, I think it's going to look like this. So they're asking for the domain and range. So the domain is not all real numbers. It looks like our smallest x value is negative 1/3, and our highest x value is infinity. But the range is all real numbers, so it's negative infinity to infinity. So which one will that be? This one, right? Negative 1/3 to positive infinity, and then negative infinity, positive infinity. There we go. So this was Aleks Exam test 4. Okay, I'm going to stop there.